All right, we have our 6th grade science project here. Currently the USB cord for the adapter is just tucked away. We're not reading sensors from it, and we haven't got the wireless part set up yet. So starting off with the car, we used some leftover kits from a kit called We Make, and we basically combined 2 cars together to make this little hot rod. Put some reinforcements inside, some scavenge as many parts as we could find, a RC car control arm to help transfer the impact to the back part of the vehicle so it doesn't crush. We've got a smooth surface on front. This is where the Velcro is going to go, where he can attach different type bumper assemblies so he can test plastic versus rubber versus spring. We've got a little hook here to help propel it along. The back has a heavy metal plate and an electromagnet. So right now there's full tension on everything, and the electromagnet is holding the car in place. We have a zero friction release that way. So much like the, I'll zoom out a little bit here, much like our design, we have the overhead spring so we can see the spring action work. There's a great debate on whether or not these are brake springs or carburetor springs. We found them on the wall, so I have no idea exactly how much force they have on them. Over to our 2x6, which is our impact surface. We have a hole cut in the impact surface for the cable to come through, and for the hook assembly also to pass through there. Up top, we have L brackets that have been modified to accept a 5mm shaft and pulley assembly. Cable comes up, back down to the second pulley assembly, and back out. 2 more L brackets. I will say that we didn't have Amazon when I was building science projects, but I think all the hardware together were made less than about 10 or 15 bucks. The most important, expensive part of the whole setup was probably the little car kits, but those were left over. The sensor is a whip motion sensor. It's a industrial commercial grade sensor. It works either USB or Bluetooth. Measures just about everything you'd want to measure. It has compass, acceleration, angle. Comes with a full development kit and can report basically anything that happens to do with motion and physics. So it's basically a universal physics sensor. About $25, I think, on the Amazon. And of course the electromagnet is off a security door. It's about $11, $15, depending on what strength you get. This is a 130-pound electromagnet. So we're going to have a launch button, a red button, but for the meantime I will just unplug the power to the electromagnet, which should pull the car and make a nice impact against the wall. So as far as the science project goes, we will have the Velcro in the front. Ty will have, he'll have to make up several bumpers on his own of different materials, and we will connect the cord to the laptop, or if we've got the Bluetooth working, and we will make runs, and once it makes the impact, we'll have the full acceleration curve, the deceleration curve, and if the car spins out of control, things like that, we'll have all those sensors, but he'll be able to take that data and draw his conclusions on what materials make a good bumper to reduce the G-forces impacted on it, the sensor, which is affect our person. So I'm going to disconnect it. We're going to crash into the wall, and let's go. So here's my cable, and we're going to disconnect in 3, 2, 1. And they're probably dead. And that's it. And we just reset the machine, plug the magnet back in, and we're good to go for another try.